So, if the bridge can do all this wonderful stuff, why do we need routers? The problem is that bridges do everything based on MAC address, and there is no way to actually know where a MAC address is located. MAC addresses work fine within one network, but they're insufficient for communication between different networks. A MAC address is similar to your Social Security number. This identifies you perfectly. However, finding someone given only their Social Security number is virtually impossible. We need a better system. Because routers route traffic between networks, they need to forward communication based on a more specific addressing scheme. Routers use network addresses. One part of the network address identifies where the device is located, and the other part specifically identifies the end station. It's important to remember that even when using network addressing, the MAC address is still required. Now let me state this clearly. Both addresses, the MAC address and the network address, are required for communication to occur. Routers also have the ability to share information with other routers. This is the foundation of how routers work. Let's go back to what I said earlier. A router must be configured. When the router is configured, the network manager tells the router which networks are connected to which ports. In large networks with many routers, each router is configured to connect to different networks. Once this is accomplished, the routers communicate between themselves and exchange information about who is connected to which networks. This way, each router will have some idea where all the networks are located and can forward packets appropriately. Routers can exchange this information dynamically, or, for better control, all this information can be manually configured into each router. Manual configuration is a lot more work, but if a very secure and accurate network is required, it may be the best choice. Once address information is configured, all the routers can communicate. Routers are also able to limit communication. A router can be configured to only allow some networks to communicate to others. In addition, routers can be configured to control communication between individual users through the use of access control lists, or ACLs. Using ACLs, specific workstations can be allowed or not allowed access to other networks or devices. Okay, let's take a quick hop through the network. And I say hop because that's what packets do. If a packet needs to go through 3 routers to reach a destination, the destination is said to be 3 hops away. When one device needs to send information to another that's located on a different network, a router must be used. The source device will generate a packet with the network address of the destination. However, it's important to note that the MAC address for this packet is that of the local router. Remember, MAC addresses are used for local communication, so the MAC address is used to get to the router. When the router receives the packet, it consults its database and determines if the destination lies on the other side of the next router. If so, the packet is forwarded with the network address unchanged. But what about the MAC address? What MAC address should the first router add to the frame? Hopefully, you said the MAC address of the next router, for that is the correct answer. When the second router receives the packet, it consults its database and forwards the packet on. Once the router that is local to the destination is reached, the packet is sent to the MAC address of the destination end station. The key point to learn from this is that the network address stays the same all across the network, but the MAC address changes hop by hop. Here's another analogy to describe the difference between a network address and a MAC address. Imagine taking a bus across town. You know the final address where you're going. That never changes. However, along the way you may need to ride several buses, all with different numbers, to get there. The different buses you take are like the different MAC addresses a packet uses to get to its destination. But all the while, your destination address, or the network address, stays the same. Routers have the ability to modify a MAC address to find the best path through the network. Bridges do not.